Okay, let's put this situation using the number of bacteria model. So I'm going to write down this as n of t, and this equals n naught 2 raised to the power of t by 4. I put this as 2 raised to the power of t by 4 because the bacteria doubles every 4 minutes. And here n naught represents the initial amount of bacteria, and n of t represents the number of bacteria at any time t. And we're also given this, that is after 53 minutes the container is full, that is when t equals 53, it has grown to a bacteria, or we can say that n of t equals 8 liters. So there are about 8 liters of bacteria after 53 minutes. Now let's put this into this equation, and we can solve for n naught. So I'm going to replace n of t by 8, and this equals n naught we have to find. So I put this as n naught times 2 raised to the power of replace t by 53, and so this is 53 by 4. Now let's solve for n naught. So we get n naught equals, we divide both sides by 2 raised to the power of 53 by 4. So this is the expression for n naught, or the initial amount of the bacteria in the 8-liter container. And this means we can rewrite this number of bacteria model. So therefore we have n naught, I'm sorry, this is n of t, and this equals replace n naught by 8. So we will have 8 divided by 2 raised to the power of 53 by 4 times 2 raised to the power of t by 4. In fact, we can combine these two powers of 2 using the exponent laws. That is, we can subtract the powers and put this as n of t, and this equals 8 times of, I put 2 raised to the power of t4 minus 53 by 4. Let's simplify this. So this equals 8 times of 2 raised to the power of, we have the common denominator 4. So we can put this as t minus 53 over 4. So this basically represents the number of bacteria model, that is n of t equals 8 times of 2 raised to the power of t minus 53 over 4. And now to determine the time when the bacteria has grown to the full capacity of the container, that is 8 liters. That is, it has grown to a 8-liter amount of, I'm sorry, it is grown to a quarter of the container. So let's determine the time. So basically we have to determine the time when n of t equals quarter of the container. So the full capacity is 8, and the quarter of this container will be 8 by 4, and this equals basically 2 liters. So we have to plug in n of t equal to 2 into this equation and solve for t. So let's do that, and when we do that we get 2 equals 8 times of 2 raised to the power of t minus 53 over 4. Let's divide both sides by 8. So when we do that, we get 2 over 8, and this equals 2 raised to the power of t minus 53 over 4. And so this gives 2 by 8 is 1 fourth. And this equals 2 raised to the power of t minus 53 over 4. Let's apply natural logarithm to both sides. So we get natural logarithm of 1 fourth, and this equals natural logarithm of 2 raised to the power of t minus 53 over 4. Now we can put this expression into front using the power law of natural logarithm. And so this equals t minus 53 over 4 times natural logarithm of 2. And here on the left side we have natural logarithm of 1 fourth. Now we can solve for t first by dividing both sides by natural logarithm of 2. So I divide by natural logarithm of 2, and this means this will get removed from here. Now I multiply both sides by 4, so that I get 4 times of natural logarithm of 1 fourth, and this is divided by natural logarithm of 2, and this equals t minus 53. So we have to add 53 to both sides to solve for t. Let me rearrange for t, and so this equals 53 plus 4 times of natural logarithm of 1 fourth divided by natural logarithm of 2. And so we can put this expression into the calculator, and when we do that, we get exactly 8. So this t equals 53 minus 8, and this equals 45. So we see that it takes about 45 minutes so that the bacteria grows to 1 quarter of the container.